In this video, I'm going to share the steps to synchronize the Ouster LiDAR timestamp with GPS. The first part is about GPS module settings. This is the GPS module I used in my test, and this is a hardware connection. I utilized a power bank to supply power to the GPS module. The U-Center software can be used to configure the GPS module I used in my test. Once the connection is established and the GPS antenna receives good signal, we can see the messages sent from the GPS module. By default, that GPS module sends out multiple types of NMEA messages. Ouster LiDAR only accepts GPRMC messages. We can use a keyword filter to only display the GPRMC messages. But in order that the GPS module only outputs GPRMC messages, we need to disable other types of NMEA messages. Now the GPS module only outputs GPRMC messages. And now let's save the configurations. The GPS module configuration is finished. It's very easy, right? Then let's take a look at the connection through the interface box. To achieve time synchronization functionality, some parameters need to be configured. There are several different ways to do so. Accessing the LiDAR by typing the IP address in a web browser and setting the parameters is the most convenient way. For GPS time synchronization, timestamp mode needs to be configured to time from SyncPulse in, and multipurpose I/O to input NMEA UART. Multipurpose I/O pin needs to be connected to a TX terminal of the GPS module to receive GPRMC messages. SyncPulse in pin is connected to the PPS of the GPS module. And then the NMEA polarity and NMEA baud rate. NMEA leap seconds by default is 0. That means the reported time is Unix epoch time. If you want the timestamp to match the TAI standard, please configure the NMEA leap seconds to 37. After you configure the SyncPulse in polarity, you can click the Apply Configure button to activate the new settings. If you don't want to lose the settings after restart, please click the Persist Active Configure to save the configurations permanently. Now let's go to the dashboard page. After clicking the Apply Configure button, the LiDAR will go through an initializing process before new settings take effect. Oops, an active alert. Let's go to the Diagnostics web page to check the detailed information. It says Multipurpose I/O connection warning. Either the hardware connection or the polarity setting will cause this warning. Let's check the setting first. Remodify the NMEA polarity to active low. and then click the Apply Configure button to activate the new settings. Also the dashboard to check the status. Oh, lucky me, only a wrong parameter setting. Now we can use the HTTP API to check for synchronization. SyncPulse in logged. Valid GPRMC message received. NMEA logged. And the synchronized timestamp. We can refresh the web page to update the response. Besides, we can also use the command line to send the HTTP GET request to acquire the response to check for synchronization. By checking the LED status in the interface box, we can also know whether the time synchronization is successful or not. Now the third part, using a pigtail cable to connect the GPS module. This is how I connect the hardware. For NMEA UART message transmission, we need to connect the ground wires of the LiDAR and the GPS module together. The parameter settings also apply to pigtail cable connection if you are using the same GPS module. Similarly, we can also use the web browser to send HTTP API to check for synchronization. And we can also send the HTTP GET request to a LiDAR to check for synchronization. Then let's check the synchronized timestamps. There are several different ways to do it. My approach is to utilize the Ouster root driver to check the timestamps contained in the header of the topic. In the last part of the video, I listed several possible reasons that might cause time synchronization failure. Thank you for watching this video.